Hello everyone, I welcome you all in this course Introduction to Sequence Stratigraphy, and today we will be introducing into the basic concepts of sequence stratigraphy, where we will discuss about some basic aspects about different sequence stratigraphic elements. So, when we talk about sequence stratigraphic elements, commonly we refer to the strata which are arranged in different orders, and we give different names to them like sequence, like system strat, and always this strata or package of strata, these are associated with certain boundaries. So, we commonly call them as sequence stratigraphic boundaries, and these boundaries and the system strats, the sequence, they together are counted as the sequence stratigraphic elements. So, in this class and also in successive classes, we will be discussing about the basic concepts of different types of sequence stratigraphic elements. So, to start with, I will refer back to that basic plot of base level fluctuation. So, for that I will again ask you to go back to our previous class on base level fluctuation curve, and based on that we defined the transgression and regression. We defined a TR curve, transgression regression curve, where we discussed that the interplay between sedimentation and base level fluctuations at the shoreline leads to different types of conditions, and those different conditions leads to shift in the shoreline position, which we define as either a transgressive condition or a regressive condition. And within regression we can have normal regression or forced regression. So, during one complete cycle of base level shift, based on the rate of sedimentation and based on the rate of base level change, we can get different types of scenario. So, I can try to explain to you with that simple diagram again. So, the base level curve was simple like this. It was going on like this, where the midpoint is something like this. This is the time axis. Also, we have seen earlier that the rate of base level change, that goes on at very high rate over here in this part. The rate of base level change is quite low over here in this part. Again, the base level fall, its rate is very high. Again, the rate of base level fall is very low, and in that way it goes on. So, when we compare this with the rate of sedimentation, considering the rate of sedimentation to be uniform, then what I have seen, that this is the phase when the base level is rising at very high rate and overpacing the rate of supply of sediments. In that case, what we get over here is the transgression. So, this is the point up to which we can find out one boundary. So, this part is the transgression part. After this, up to this point, the base level is still rising, but the rate of base level change is slow with respect to the rate of sediment supply, and in response to that what we get is a simple normal regression. So, that will continue up to this point. So, again we are getting another boundary over here. That point indicates the start of fall or a kind of changeover in the base level curve from rise to start of fall. So, from that point of fall we get the forced regression, and that goes on irrespective of the rate of sedimentation. So, how long will that forced regression will go on? Up to this point till the base level is falling. So, this entire part, this is the forced regression part. This is another turn around point where the base level starts rising. But at this point, in this part of the base level rise, the rate of rise of base level is lower than the rate of sedimentation. So, somewhere here again we will get a boundary which will indicate a changeover in terms of rate of change of base level. So, up to this point the rate of base level change is lower than rate of sedimentation. So, what we get here is a simple normal regression. Then in this part the rate of rise of the base level is more than the rate of sedimentation. So, again we get a transgression. So, already we have seen this diagram and we have discussed about this diagram in detail, but this diagram is very important. That is why I am again explaining this to you, because this is the fundamental concept for identification or understanding of different sequence stratigraphic elements, where we try to identify these 4 different boundaries. The entire concept of elements of sequence stratigraphy, they are based on these 4 boundaries. So, what are these 4 boundaries? Number 1 is the start of forced regression, this is boundary number 1. Second one, the end of forced regression and start of a normal regression. So, that is boundary number 2. Number 3 is the end of normal regression and start of transgression, that is boundary number 3. And then we get the 4th one, which is the end of transgression and start of the normal regression. So, that normal regression will continue up to this point, the next boundary, which is again the boundary number 1 from where we have started. So, evidently we are getting 4 distinct boundaries. Again I am telling you, number 1, start of forced regression, number 2, end of forced regression, number 3, end of normal regression, number 4, end of transgression and start of the next normal regression, which is same as this part. So, all the sequence elements, particularly when we talk about the system tracts, they are confined in between these 4 boundaries. So, in sequence stratigraphy, we try to define these 4 boundaries very precisely, as they commonly demarcate the change in the stratal stacking pattern. As you can see over here, say the boundary between 3 and 4, this is a transgression. So, within transgression we know the stratal stacking pattern will be retrogradational, fining up in nature. Then after that we are getting this normal regression. So, in normal regression we know there should be coarsening upward succession, that will be progradational succession. On that we will get the forced regression. So, in forced regression we know it will be again a progradational coarsening upward, often associated with some truncations, or maybe the truncation may be very prominent and there will be nothing deposited and there will be entirely truncation. And after that we are getting this normal regression between 2 and 3, where again we will get a coarsening upward, a progradational stratal stacking pattern. So, starting from this transgression to the next transgression, what we get? We get initially during the transgression a fining upward succession, followed by a coarsening upward, which is progradational plus aggradational, followed by some succession which is again progradational with some erosions, or maybe this is entirely erosional, followed by another progradational pattern, followed by the next transgression which is a retrogradational pattern. So, starting from here to here, this entire portion is progradational in nature, whereas this portion is retrogradational, this portion is retrogradational. So, within one complete cycle, starting from this rise to the next rise, within one complete fluctuation we get one transgression followed by a very dominant phase of regression. So, in this diagram, if I want to draw the TR curve, so that TR curve will appear something different. So, if I draw the TR curve, so this particular point, this is the peak of the transgression. Now, from here the regression is starting and this regression is going on up to this point. So, this entire phase is the regression, and then from here again the transgression is starting, which is at its maximum over here. From here again the regression is starting. This yellow line, this is the TR curve. So, this curve is not exactly superposed on the base level curve. It is out of phase with respect to the base level curve. So, what we are getting over here, the peak of the transgression is not matching with the peak of the base level rise. The peak of the regression is not matching with the peak of the base level fall. So, this changeover from transgression to regression, reaching to the peak of the transgression, changeover into the regression, followed by normal regression, forced regression, again another normal regression, and then again changing over to transgression. This changeover during ideal base level fluctuation is the key for identification of the sequence stratigraphic surfaces and other elements like system strats. So, when we talk about these 4 boundaries, the first one, that is the onset of forced regression, onset of base level fall at the shoreline. So, commonly this is accompanied by a change from the sedimentation to erosion or sedimentation to bypass of sedimentation in the fluvial system to shallow marine environment. If we move on to the deeper part, there we can get change in phases, but there will be no erosion. Apparently, there will be no erosion, or the effect of erosion, which is mostly confined into the marginal part of the basin, will not be evident over there. So, onset of forced regression or the onset of base level fall at the shoreline is best evident at the shoreline area or within the fluvial part. The second boundary that I have told you in the previous diagram, the end of the forced regression and start of the normal regression. So, this is end of forced regression, end of base level fall at the shoreline, and that also marks the start of the next normal regression. So, this particular boundary marks a change from degradation to aggradation in the fluvial to shallow marine environment. During the forced regression phase, there is complete degradation of the entire sedimentary package. There is a lot of erosion, and then during this normal regression, from this point onward, there is a start of positive accommodation creation, and that leads to aggradation of both fluvial and shallow marine successions within the marginal marine environments. Now, if I look into the third boundary, which is the end of regression, which actually marks the changeover from regression to transgression. So, this end of regression, if I go back to that particular diagram, so this is the point, this boundary 3, this is the point. So, this point demarcates that changeover from regression to transgression. This is the end of the regression, and this particular phase is the phase of rising of the base level. So, boundary 3 is end of regression during base level rise at the shoreline, which marks the turnaround point from shoreline regression to subsequent transgression. And then comes the fourth point or fourth boundary, which is the end of the transgression during the base level rise at the shoreline, and this particular point, this particular boundary marks a change in the direction of shoreline shift from transgression to subsequent regression. So, if I look at that particular diagram again, so this is the point where we are getting the peak of transgression and end of transgression, and then the start of the normal regression, which we have already discussed over here. So, these 4 boundaries, they demarcate the nature of stratal stacking pattern, the nature of shoreline shift in response to the base level changes. So, identification of these 4 boundaries are very important, very crucial for understanding of the different sequence elements. So, now if we want to talk about the elements itself, so we can define sequence stratigraphic boundaries and system strats, which are considered as the sequence elements or sequence stratigraphic elements. So, commonly the sequence and the system strats, which are the constituent units within a sequence, are commonly bounded by different key stratigraphic surfaces, which signify specific events in the depositional history of the basin. So, such surfaces can be conformable or can be unconformable depending on what kind of depositional pattern is going on, what kind of conditions are prevailing, and in which part of the basin we are looking at for identification of that particular boundary. And this kind of boundaries commonly mark changes in the sedimentation regime across that particular boundary. So, when we talk about the identification of these 4 boundaries that we have just discussed, they are the key to identify the sequence stratigraphic boundaries. On the other hand, when we look at the system tracts, they are the linkage of contemporaneous depositional systems forming the subdivision of a sequence. This is the definition of system tract. So, a system tract commonly includes all strata which are accumulated across the basin during a particular stage of shoreline shift. So, we get one package of strata formed during the transgressive phase. So, when the transgression is going on, that is a phase of shoreline shift, shoreline is moving towards the land, and during that phase we get package of strata formed in the coastal area, formed in the fluvial area, formed in the deep marine area. So, when we talk about the system tract, say for example a transgressive system tract, then we include all the strata which are formed in the deep marine, marginal marine and fluvial system. All these strata together will define the system tract that we will call as a transgressive system tract. So, a system tract includes all strata accumulated across the basin during a particular stage of shoreline shift. So, if I refer back to the diagram, and with respect to the diagram, if we want to understand what are the different elements, sequence stratigraphic elements that we can define over there. So, again I am drawing that diagram. This is the base level curve, and now we have the tear curve. I can draw the tear curve which goes on like this, like this. So, this is the boundary number 1, or rather we can start from here. So, this is boundary number 1 as we have discussed earlier, the onset of forced regression. This is boundary number 2 which is the end of forced regression. This is boundary number 3 which is the end of regression and start of transgression, and this is boundary number 4 which is the end of transgression and start of the next regression. So, in terms of sequence stratigraphy, if we want to identify what are these boundaries, so in the marginal marine area, this boundary number 1 which demarcates the onset of forced regression is commonly called as BSFR. The full form is basal surface of forced regression. Then when we are moving on to this part over here, boundary number 2, we can get a new surface over here which demarcates the end of the forced regression and start of the normal regression. So, in the deep marine part or in the marine basin, commonly we identify this boundary as a correlative conformity. Now, this particular term correlative conformity, this is actually associated with another surface which commonly forms in the marginal marine part. So, this particular point, when this forced regression is starting, in the marginal marine part we can get extensive erosion and bypass, and that extensive erosion and bypass will lead to a surface. We commonly identify that as an unconformity surface. So, that unconformity will continue up to that extent where this forced regression will have its direct effect in terms of falling of the base level. So, it will be definitely confined within the fluvial part and to some extent into the marginal marine part. But during the same phase of forced regression, if we move on to the deeper part of the basin where the base level has fallen down, but still water covered and sedimentation is continuous over there. So, we get a conformable succession over there. Any unconformity is not formed in that part. So, what we get over there? A final surface which we mark as the correlative conformity. Now, correlative with what? Correlative with this unconformity. Unconformity formed in the marginal marine part. So, that correlative conformity surface will form in the deeper marine part, and that will demarcate the end of the forced regression in the deep marine part or distal part of the basin. Whereas, in the proximal part of the basin, this entire forced regression will be demarcated by unconformity. So, the force regression, this entire part is the force regressive part and it is bounded by these surfaces. Either it is a BSFR followed by a correlative conformity. So, in that case we are getting a lower bounding surface and an upper bounding surface, and within that we are getting a succession of strata, and when that package is formed, that package of strata is preserved irrespective of that erosion, we commonly call that particular strata as one system stract, because this is forming during a force regressive phase, during one phase of shoal line shift. So, that particular package of strata is commonly called as falling stage system stract, FSST. So, when the unconformity is forming, that means extensive erosion is going on, then we will not get this FSST, particularly in the fluvial part, particularly in the marginal marine part. There, due to this erosion or sediment bypass, we will not get FSST. But in certain portions, even after the erosion, certain package of strata formed during the early phase of force regression may get preserved, and on that the late phase of force regressive condition may get preserved in the distal part of the basin, finally covered up by this correlative conformity. So, in such cases we will get a package of strata which will be defined as a system stract. So, that system stract is called as falling stage system stract, FSST. At this particular point, when the force regression has ended and a normal regression is starting, but still it is the regression is going on. So, that regression will continue up to this boundary 3, and this boundary 3 is the turnaround point in terms of TR curve where we get start of the transgression. So, what we can get over here is this particular point, regression is starting and it is continuing, initially a normal regression followed by a forced regression followed by another normal regression, and this is the entire phase of regression going on continuously in the basin, and this is the boundary which demarcates the end of the regression and start of transgression. So, this surface is identified as the maximum regressive surface or MRS, maximum regressive surface, or this is the surface demarcating the maximum extent of regression in the basin under that phase of base level fluctuation. Now, from this point onward, from boundary 3 MRS, we are getting a transgression. But before that, within this part, when this normal regression is going on, base level has started rising. So, it is producing new accommodation, and within that accommodation we will get aggregation of sediments, accumulation of sediments, and as a result a package of strata will form in the marginal marine part, in the deep marine part, in the fluvial part, and that package is identified as another system stract which we call as low stand system stract or LST. Next, after this comes the transgressive phase. So, that transgression will continue up to this point, which demarcates again a turnover in terms of change from transgression to start of the next regression. So, this particular surface, the surface number 4 or boundary 4, is identified as the maximum flooding surface, MFS, and the package of strata formed during this phase of shoreline shift, which is definitely a transgression. That package of strata formed over here is identified as a transgressive system stract or TST. Then comes this next phase. So, I am referring back over here, the same phase. So, this is the boundary 4 and 4 to 1. So, end of transgression, start of normal regression and start of forced regression, the portion in between these two boundaries, the start of the forced regression and end of the transgression. So, that phase is a normal regressive phase when the base level is at its maximum, very high, but rate of base level change is slow. So, the package of strata between MFS and this BSFR or unconformity is commonly identified as another package of strata formed over there, which is called as another system stract named as high stand system stract or HST. So, commonly we get this cycle repeating again and again. So, what we can get over here? We are getting 4 different systems tract: FSST, falling stage systems tract; LST, low stand systems tract; TST, transgressive systems tract; and HST, high stand systems tract. And these are bounded by several boundaries, and these boundaries are also very much characteristic of that particular systems tract. So, if I want to identify these systems tracts, they are commonly interpreted based on the stratal stacking patterns. As I have told you, when I am talking about the TST, it will always show a retrogradational stratal stacking pattern. It will always show a fining upward stratal stacking pattern. When I am talking about an HST, which is forming under normal regressive condition, this will show a aggradational with progradational stratal stacking pattern. When I am talking about the LST, low stand systems tract, it will show a progradational stratal stacking pattern. So, each of these systems tracts are interpreted based on their characteristic stratal stacking patterns as well as their positions within the sequence, because a sequence is commonly defined in terms of this base level curve, how the accumulation of package of strata is going on, and based on that base level fluctuation, individual systems tract will have their characteristic position within the sequence, and definitely the types of bounding surfaces, because the bounding surfaces are characteristic for each and every systems tract. So, what will be the bounding surface? That again depends on what is the nature of the base level curve, how it is changing, what is its rate of change, and how it is related to the sediment supply. So, the terms systems tract and sequence, they are specific sequence stratigraphic terminologies which are defined in relation to that base level curve and the transgressive regressive curve. As we have already seen, these two curves, they do not juxtapose. There are some out of phase relation between these two curves. So, a systems tract includes a sum of laterally correlative depositional systems. Since it is the assemblage of multiple depositional systems, hence we use the term as a plural, systems tract. So, it is not system tract, it is systems tract because it is always assemblage of more than one depositional systems. On the other hand, a sequence commonly includes 2 or more systems tracts depending on in which scale, in which way we are trying to make a sequence stratigraphic model. But always a sequence should have at least 2 or more systems tract. So, if I want to summarize what are the elements of sequence stratigraphy, if I talk about in terms of the change in base level curve and start of forced regression from there on. So, what are the surfaces that we are getting? We can categorize them in terms of, for example, those surfaces which are associated with the base level fall. So, which are associated with base level fall, the surfaces are: number 1 is basal surface of forced regression, second one is an unconformity, and associated with this is a correlative conformity surface. We can also get a surface called as RSME, regressive surface of marine erosion. So, these 4 surfaces: basal surface of forced regression, unconformity, correlative conformity, and regressive surface of marine erosion, these 4 surfaces are associated with base level fall. We will discuss in detail later on in later classes about the significance and nature of each of these individual surfaces, how we can identify these individual surfaces, what will be the changeover in terms of stratal stacking pattern across these surfaces. So, all these details we will discuss later on in later classes. If I talk about the surfaces which are associated with rising phase of the base level, what are the surfaces that we commonly get? The first surface that we will get is the maximum regressive surface. This is the first surface we will get, the maximum regressive surface. And the second surface that we will get is the maximum flooding surface. And apart from these 2 surfaces, we can get another type of surface which is commonly associated with, particularly during the initial phase of transgression, which we called as ravinement surface. Since it is associated with transgression, they are also often called as transgressive Refinement surfaces, in short TRS, and depending on the agent or mechanism of this refinement, that means erosion, we can identify them as either tidal refinement surface or wave refinement surface. So, we can get these major 7 surfaces associated with either fall or rise of the base level. Either we can get basal surface of forced regression, we can get unconformity, we can get correlative conformity, or we can get regressive surface of marine erosion. This surface I have not discussed in this class, we will discuss about this in detail later on, what is the nature of this particular surface. But definitely this will form during the regressive phase, as the name suggests, regressive surface of marine erosion, RSME. During the rising phase, already we have discussed MRS and MFS, maximum regressive surface, maximum flooding surface. And along with that, we can also get a TRS, transgressive refinement surface, which can be a tidal refinement surface or wave refinement surface. We have not discussed about this surface in this class, we will discuss about this particular surface later on. But these 7 surfaces are the primary surfaces, major surfaces that we can encounter, we can record in any sedimentary succession when we are doing a sequence stratigraphic modeling. Apart from these 7 major surfaces, we can also get few minor surfaces, which we commonly call as within trend surfaces. So, what is the meaning of within trend surfaces? That means they are not defining the boundary of a system's tract, but they are confined within the system's tract, often indicating boundary between the depositional systems or maybe a simple facies boundary. So, there are 3 different types of these minor surfaces, which we call as within trend contacts, which are basically the minor surfaces, and under these within trend contacts we can get within trend normal regressive surface, within trend forced regressive surface, and a simple flooding surface which is associated with transgression. So, again we will discuss about these within trend surfaces, the minor surfaces also in detail in later classes. Now, confined within these major surfaces, we get different systems tract. So, at the bottom part, if I draw the first boundary, which may be an unconformity or it may be a basal surface of forced regression. So, it will include the FSST, falling stage systems tract, which will be bounded by a correlative conformity surface. So, when it is unconformity, this entire portion is unconformity, and finally this boundary is an unconformity, which is correlative over here in the deeper part where we are getting this FSST. So, when it is an unconformity, there is no deposition, it is entirely erosion. After this correlative conformity, we get LST, low stand systems tract, which is bounded by the maximum regressive surface. On this maximum regressive surface, we get TST, which is bounded by maximum flooding surface, and on this TST we get high stand systems tract, which is again bounded by a BSFR or an unconformity. If it is unconformity, this is an erosional surface. If it is BSFR, it is a conformable surface. And again we are coming back over here in this part. So, it will go on in this cycle. In certain areas, we may not be able to distinguish between these FSST, LST and HST. In such cases, this entire regressive part is identified under one systems tract called as regressive systems tract, RST. So, in certain cases where the resolution of data is not sufficient enough to distinguish between FSST, LST and HST, in such cases we can refer to RST, regressive systems tract, where the entire regressive package is identified as one single systems tract. So, these are the basic elements of sequence stratigraphy, where you deal with different types of systems tracts which are bounded with different surfaces. So, there are 7 major surfaces and 3 minor surfaces, and in later classes we will discuss in detail about each of these surfaces and each of these systems tracts. So, the sequence stratigraphic surfaces may be used at least in part as the systems tract boundaries or as the sequence boundaries. So, this is about the major sequence stratigraphic surfaces. So, this is their fundamental attribute, that separates them from any other type of mappable surface. On the other hand, the within trend facies contacts, those which are the minor surfaces, are commonly the lithological changeover, lithological discontinuities within the system strands. So, such surfaces may have a strong physical expression in outcrop scale or maybe in the subsurface, but are more suitable for lithostratigraphic or allostratigraphic analysis. So, with this I will conclude this particular class. These are some of the references that you can follow for further reading on this particular topic. So, thank you everybody.